Hi there, welcome to Tech Foundation. I am Eric Obin, aka Professor. It is my pleasure to share with you what I know, and I am very grateful that you are here. Let us get started. In this tutorial, I will introduce you to the device that we'll be using for this training. Hello everyone, let us welcome Mabel. Learning Arduino is not fun if you don't have the background in electronics. This is because the Arduino board alone is not much to program or do anything important with. However, if you embed it in an external circuit, then it becomes yummy. Unfortunately, learning electronics and programming at the same time is like an army fighting on two fronts. This is because these two fields of study individually requires a lot of work to master. I have seen most people quit because of their lack of self-motivation. Because of that, you have designed Mabel to make the learning experience easy and fun. And the best of it is that Mabel decouples the electronics from the programming. So you technically don't need to be electronics savvy before you learn how to program Arduino controlled devices. The circuits have already been set up for you. All you have to do is write your programs. For those who want to learn the rigorous electronics, this tutorial will also explain the electronics behind every demonstration, and you can also follow our introduction to electronics tutorials on this same platform or channel. So with Mabel, everyone can have fun because Mabel makes you able. There are over 50 experiments that can be set up on Mabel, and as a matter of fact, you can even do more, as many as you can imagine. In this tutorial, we are going to look at the hardware of Mabel. So let's get started. Basically, Mabel consists of four main parts. We have the Arduino Uno microcontroller, then we have inputs which consist of sensors. We have inputs which consist of sensors. Then we have outputs which consist of actuators and experimental selectors. For most experiments, all you need is power from the USB cable. However, Mabel operates on a 9-volt power supply that can be connected via the DC barrel here. The 9-volt power supply is stepped down by this voltage regulator. However, you can supply the 9 volts power through the Arduino's DC barrel. So you have two ways to power your Mabel. You can do it using the Arduino's power. You can do it using the Arduino's DC barrel, or you can do it using Mabel's DC barrel. Now, only one of them can work at a time. So for instance, by default, you should make sure that this switch here is pushed to this side. By pushing this switch to this side, it activates the DC barrel of Mabel. Okay, so if you want to connect the power supply through the Arduino's DC barrel and use Arduino's onboard voltage regulator, then you will have to toggle this switch to this side. But please, unless you have an issue with your Mabel's power supply, please don't do this. So always make sure the switch is moved to this part in order to activate Mabel's DC barrel. In this microcontroller area, there are two LEDs. We have a red LED and a yellow LED. This red LED is an indicator for the 9-volt power supply, and the yellow LED is an indicator for the 5-volt output. A successful powering will cause the yellow or both red and yellow LEDs to turn on. This switch here, labeled SW3, is the reset button. This reset button is connected to Arduino's reset pin. It makes it possible to reset the Arduino without having to come down here to press on this button. Okay, so instead of coming to press on this button to reset the Arduino, you can use the one on Mabel to do the same thing. The Arduino pins have been extended on Mabel to make it possible to design your own circuit using this onboard mini breadboard or connect to an external circuit. Now, by extending these pins, it makes it possible to extend the functionality of Mabel using external shields. For instance, you can mount a GSM shield or an SD card shield on Mabel if you need it. Now, there are 5 inputs or sensors on Mabel. These are a PIR sensor, the PIR is not connected at this moment, a potentiometer, an LDR, light dependent resistor. Then we also have an LM35 temperature sensor. Then we have these 2 buttons, which can all be used as a form of input or sensors. There are also 10 output experiments. This includes a buzzer, a 10 mm common cathode RGB LED, an LED bar graph, a traffic light setup, a blink, an LED ring, then 2 7-segment display which can be used to display 2 numbers, and this represents the MSB or the most significant bit, and this one represents the least significant bit. We also have an infrared communication experiment over here. So this black LED here is the infrared receiver, and this one is the infrared LED or transmitter. We also have a relay setup here which can be used for performing experiments involving switching of high voltages like AC or even high DC voltages other than the one that comes with Mabel. Before an experiment can be performed, it has to be selected using the input or output selectors respectively. Now, by toggling these switches, you select the experiment corresponding to it. For instance, if I want to perform the blink experiment, all I have to do is toggle this switch up, and that would select the blink experiment. So when I'm done and I want to perform an experiment with a buzzer, again, I'll bring the blink down and move the buzzer up. That selects the experiment. It is as easy as that. Unlike the output experiment, input experiments have to be enabled first using the enabled switch, which is labeled EN. That is this particular selector here. Okay, so you first have to move this up to activate the entire input sensors or input devices before you can actually go ahead to select the experiment that you want. So let's say that I want to perform the PIR experiment. I will first have to move the EN button up, then the PIR button up. You have to do this too, else if you move the experiment without the enable pin, the experiment is not going to work. Now, each experiment has a blue LED closer to it. These LEDs indicate when an experiment is selected. So for instance, if I select the traffic light experiment, the blue LED closer to the traffic light would turn on to indicate or to show you that that experiment has been activated. Because some pins are shared between experiments, some experiments cannot be performed together. I will show you how to find out which experiments cannot be performed together in later videos. That is all about Mabel. Very simple concept but very efficient. In the rest of the tutorials, I will teach you the concept of Arduino programming and demonstrate them using Mabel. I will also explain the circuit behind each demonstration and also help you set up your own external circuit when they need be. I encourage you to get your copy of Mabel by contacting the numbers or emails on the screen. It will be okay to build your own circuit along, but it would be efficient to have a Mabel. Besides, any Mabel you buy will help us fund these tutorials and make them available for free. Thank you for watching. Remember, if you can manipulate the building blocks, you can build anything. Don't forget to subscribe and share this video. Also, let me know what you think via the comment box. Make sure you understand this episode before moving on to the next. I am Professor, and this is Tech Foundation.